You can see on this first screen that I put in the top right corner there, right up here, this is not a homework problem, but all of your homework problems that are going to be dealt with in, excuse me, page 318, 14A through E. These guys are all going to be solved in exactly the same way that I'm going to show you right now. This is actually a follow-up video to what I was doing just before in my time frame, and that is showing you how to do the pass-along and using this chart to go from anything on here, atoms, moles, or grams, to anything else on here, grams, moles, or atoms. And I recommend that. I think the title on that video is How Many Steps Are Needed to Calculate Grams, Moles, Atoms, which you see right here. This video and that were both uploaded to YouTube on the same day, so they'll be right together. Now, what we do in all of these problems is the first step is always going to be putting the given, which in this case is 8.4 times 10 to the 20th, magnesium atoms over 1. Our next step has to be figured out by being aware and understanding this chart. So the next step is, since we're starting with atoms over here, we've got to use AVO to go to moles. And that's this equality. Now, since we're given atoms, the number 6.02 times 10 to the 23rd that matches atoms is going to have to go on the bottom of the next step. So we're just going to go right to the next step by going here, and we're going to have magnesium atoms, and the 6.02 times 10 to the 23rd, and on the top is the other side of that equality, which we see here is 1 mole. And so once we've done that, we're good to go, and we've got our first fraction, 1 mole of magnesium atoms. Now, our next step is, again, right off the chart, and that is by we're sitting at moles now because we've just used this fraction. We made this equality into a fraction. Now we're going to take the moles and use this equality off the periodic chart, okay? And the periodic chart gives us the mass that is equal to 1 mole of any element. And so we go to the periodic chart, and you can see magnesium's 24.3. Now normally I only require 3 sig figs and answers, so we're going to use the 24.3 from that screen, and we're going to put that as 24.3 grams is equal to 1 mole. And you see we've got magnesium atoms here, canceling magnesium atoms here, and then we have moles of magnesium. I should really include moles here, and we're going to have moles of magnesium down here, and the mole side of that equality has a 1 next to it, so that becomes the coefficient there, and the gram side over here is going to come up as 24.3 grams, and now we can cancel out moles with moles, and we are set to do our calculation. So do this on your calculator right along with me. You'll notice that our first number is 8.4. Now what we do is we come on over to the calculator, and we're going to put in 8.4. Next, we have to decide where the next number is that we're going to use. And that number is right here, 6.02. Notice I am not putting in the power of 10 here or here. I'm going to save that for a later calculation. So I'm putting in the 6.02, and it's on the bottom of the fraction. The way you tell your calculator your next number is going to be on the bottom of the fraction is you hit the divide sign, and you hit that before you put the number in. So now we put in the number that we had from over here, the 6.02, 6.02, and now we're going to look for our last number, and the last number is sitting right here. Now that's on the top. So the way you do that is you tell your calculator the number's on the top by hitting the times sign before you put in the number. And then you put in this 24.3, 24.3. And now all that's left is to figure it as the final answer, and we get 33.9 when we round. So let's go back here and let's put in our 33.9. Now the next thing we're going to need to do is look at the powers of 10. The powers of 10 are 10 to the 20th divided by 6.02, whoops, not 6.02, but 10 to the 23rd. 10 to the 23rd. What we do when we divide powers of 10 is we subtract the bottom number of the fraction, or the bottom exponent. There we go, got it out. Bottom exponent is going to be subtracted from the top exponent. And that's why we come up with a number of 10 to the minus 3. Now, that 10 to the minus 3 has to be put into our calculation, and we're just doing that as a side. So I put in my 10 to the minus 3, and now I have completed the calculation, except for the fact that we have to move the decimal from here to here, which is one place to the left. Okay, let's put a little arrow in showing that we're going to the left. Now, a power of 10 that is negative moves the decimal to the left. And the way you always know that is by your number line. The number line has the positives on this end and the negatives on this end, and this is 0. Straight out of your math class. Okay, that's another little aside. But let's focus now on our actual calculation. Since we have to move that little number, or the decimal, off to the left, we are going to decrease that power of 10 because my arrow here and my arrow here are going the same way. So if I don't make this a smaller number, we're going to go too far to the left and we will have changed the number. So the actual number for this guy winds up 3.39 times 10 to the minus 2. I know that's a bigger number, but I don't want you to think whether the number is bigger or smaller. Concentrate on the decimal. And when the decimal is got to be moved to make it scientific notation, which is what we had to do here, since it has to be moved, draw a little arrow down there and that'll tell you which way you moved it. And from up here, we see that the two arrows go the same way. Same means this number has to decrease. And that's how you deal with your powers of 10. And this guy is your final answer. I just realized I did not put in the units of measure. The unit of measure is right up here in grams, and this is grams of magnesium. And that's your total grams of magnesium in your answer. And that's how you solve these kind of problems. I hope this helps.